Hi, my name is Guilherme, and this is the presentation of my paper, Techno-Economic Assessment of Concentrated Solar and Photovoltaic Power Plants in Brazil. This is an overview of my poster. Um, as for a little introduction, hydroelectric plants constitute about 62% of the installed power in Brazil. There is risks associated with that, mainly due to the high dependence on rain cycles, right? So an hydric crisis, for example, could prove catastrophic to our electricity network in Brazil. And this has happened in the past. So how can we avoid this? Solar power could prove an interesting solution to that, mainly due to the high solar irradiance levels here in Brazil. But there are problems. The main problems are high costs. It's very expensive, the solar technology overall, and the lack of incentives here in Brazil, as there are not enough viability studies here. um, the decision makers cannot know the benefits of the CSP technology, and cannot know the difficulties in implementing these solutions here. And there is no way to attract investors with these limitations if we do not know how these technologies work. So in this study, to propose a little answer to these problems, four CSP technologies are contemplated: solar tower, parabolic through collector, linear Fresnel reflectors, and a de-Stirling system. A large-scale photovoltaic plant is also studied. All of them have the same size, 100 megawatts. As for the methodology, it's divided in two parts. The first part, highlighted in red, consists into the validation of input data. Since there are no CSP plants to study here in Brazil, it is crucial to obtain this data elsewhere. But where would I obtain it? There are technical reports on other countries, papers that have analyzed the CSP technology, and all of this can be integrated and simulated using the System Advisor model software. Well, with this in mind, after validating this data, that is, I must generate the same results as the references. If this is possible, then the technology, the input data is considered validated. After validation, there is the second phase, highlighted in green, the technical and economical analysis of the validated plant. Four main indicators are used in this, especially in the economic viability assessment: the net present value, the levelized cost of energy, payback time, and modified internal rate of return. As for the results, they are divided in two categories as well: the technical performance and economic performance. As for the technical performance, well, it can be noted from the table 1 that ST solar tower plant has the overall best technical performance. It generates more energy and has a higher capacity factor than the other plant studies. But it comes with a cost. It requires a large area in order to operate. So the DS systems, for example, they cannot generate much energy, but they have a high efficiency, right? This is expected, mostly because of the tracking systems utilized in this technology. As for the PTC and LFR technology, they have a similar performance in terms of energy production, but the PTC requires a larger area. So if area is a parameter in question, this should be considered in the analysis. As for the economic performance, it is important to note the CSP technology is not viable in Brazilian territory. The NPV is negative, is very low, in fact, and the rate of return, the internal rate of return, is much lower than the expected discount rate of roughly 7%. The payback is very high, much higher than the plant's lifetime. But the PV systems have a fairly good performance, right? The investment in this case would not be advised, right? Investment on CSP technology, but in PV, this is mainly due to the fact that PV is well established here in Brazil. The prices are lower, and we know how we can produce some photovoltaic. We can work with silicon and etc. So it reduces prices, right? Considering this scenario of economic unviability, a sensitivity analysis was proposed. What does it do? It must the sensitivity analysis studies how certain parameters influence on the economic viability, mainly the economic indicators, NPV, levelized cost of energy, etc. So, two parameters were considered in this study: the energy selling price, right, the auction prices, and the installation costs. Here, the picture shows the variation of the energy selling price in the x-axis, and how does the NPV fares in comparison, right? How does the NPV reacts to that? And there is a highlight here. The red dotted line shows the point of economic viability. If the NPV is higher than 0, then the system is considered viable. Note that for the DS system, the DS plan, the price should be much higher than the others, right? This is why is that? Is because it doesn't generate enough energy to compensate for the costs. The internal rate of return is also analyzed here, and it has a similar performance to the NPV, right? The energy selling price is an important factor and should be considered, especially on the early phases of implementation of CSP technology. The last picture shows that the NPV sensitivity to variation on the installation costs, right? And there is the same problem of the DS system. It has not a very good performance compared to the others, but it should be noted that installation costs have significant impact on all of the variables. Now, considering the data acquired, considering the sensitivity analysis, a last question is asked: could it be? Could CSP technology be viable one day here in Brazil? What is if some conditions were met? Could it be viable? This is the optimistic scenario proposed in this study. Well, considering a cost reduction of 50% on all CSP technologies, an average energy price of $88, and reduction of 50% on the electricity transmission tariff, there are good results. All of the CSP technologies benefit from that. The NPV now is positive for all of them, and it is fairly high. The internal rate of return now it's higher than the threshold considered. The payback time is fairly low, right? This is made with, according to several reports, mainly IRENA, right? A report of the global costs of energy and includes CSP generation. Now, for the conclusions, well, CSP technology is currently not economically viable in Brazil. There is a high import dependence, and this influence in high costs. Indicators are sensible to installation costs and auction prices. Proper incentives could turn CSP technology into a viable alternative. DST plant being the most attractive CSP technologies in all scenarios, technical scenarios and the optimistic case as well. PTC and LFR plants occupy less space and has a good performance. In this study, overall, provide viable tools that can enrich the decision-making process about incentive politics to solar generation here in Brazil. If there is a way to attract investors, to generate more knowledge in the CSP area, solar area overall, then CSP as solar generation in general could be viable here and could improve on the diversification of our electric network. Well, I'd like to thank you all for your attention, and have a good day.